So, hello everyone, this is Akshay here, and I know a bit late as usual of my timing that I upload the video. But let us continue with the today's question. And if you are new to this channel, please like, share, and subscribe so that you can learn, maintain, and grow our streak together. Let us see what the today's question is. The name of the question is Walls Coloring 2. It's a hard category question, but once you read it, you will realize that this question is the same question we have done in past. So let us read the question, and then I will tell you that what are all the techniques and which is the question which is exactly similar to this. So there are rows of n walls in Geeklands. The king of Geekland ordered Alexa to color all walls of the on the new occasion of New Year. Alexa can color each wall with one of the K colors. Okay, the cost associated with the coloring each wall with a particular color is represented by a 2D cost array and cross K. For example, the first entry is the cost of coloring the first wall, and the second entry is the cost of coloring the first wall with the different colors, similarly K colors, right? So if you see 1, 5, and 7, right? So the first row is representing the wall 1, but you have three options to color the same wall, right? Similarly for wall 2, you can color the wall 2 with these three options, 5, 8, and 4. The cost will be 5, 8, and 4. So you have to find the minimum cost to color all the walls such that no two adjacent walls have the same color. So I guess you will be able to defer that what was the question that we have done in the past. Yes, maybe you are right. So the question was distinct coloring, right? I don't know the day number. Let me search for you. Okay, so I searched for it and it was day 103, right? You can visit this problem again, or if you have done this problem, then it would must have strike to you that okay, that's the same problem, right? So let us see that what we have done in this distinct coloring problem. So again, there were n equals to 3 was given, but at this problem, the colors were defined that for all the particular walls, you have three colors, R, G, and B. In the current problem that in the current problem that we have, the colors are also varying. You will have K colors. Sometimes K will be starting from 1 to let's say the constraint is where 10 power 3. So you can have 10 power 3 colors, right? So the way we did this previous question was what we did was, let me explain it to you again. And before I explain you, you must pause this video now. Go back to the problem. If you have done it, if you have completely understand the problem, it would have definitely clicked to you. And try the problem yourself right now, because I have given you the previous problem where you have invested your time. So it should not be like you solve the problem first and then you forget, right? So it must would have clicked you, right? So let us see. So this was the input for that thing, and what we did, we made a dp array, right, of n cross k. Here the n is 3 and k is nothing but the colors, the number of colors. So n is also 3 and k is also 3. So let's make a, a n cross k array. We will discuss this case and then we'll come back to the question, right? So the first thing, so this vertical thing is representing walls. N is representing walls. So this is first wall, this is second wall, this is third wall, okay? And the first wall has the the first wall has the um, possibilities to color. This is with, if we color it with R, G, and B. The R is costing 1, the G is costing 2, and the B is costing 3, right? R, G, and B, the first column for the first wall, right? Okay. So what I need to do is from the second wall. Okay, so suppose was n equals to 1. The question was saying कि अगर n equals to 1 के लिए आपको you need to find the answer. Then we would just have returned the minimum of this row, right? And that would have been my answer for wall 1, right? But there are some other constraint also that we have wall 2 and 3. So what we were doing in the previous were that in the second wall we were considering the color first. That what's the color? Let's take the color for coloring R, and what's the minimum value, right? We have to take from the previous wall, क्योंकि अगर हमने second wall को भी R से color कर दिया, then you cannot take the same cost of coloring of with red color for the previous wall. You have to take the minimum of these two, है ना? हमने सेकंड वॉल को आर से कलर किया, देन पहले वॉल को ऑब्वियसली या तो जी से कलर करना होगा या तो बी से कलर करना होगा, और उनमें भी क्या मिनिमम, बिकॉज द क्वेश्चन आस्क्ड दैट. सो आई विल से फ्रॉम 2 to 3 द मिनिमम इज 2, सो 1 + 2 दैट इज 3, राइट? तो मतलब मैं किससे कंपेयर नहीं कर रहा, आई एम जो सेल जो मेरे जस्ट ऊपर है मैं उससे कंपेयर नहीं कर रहा, राइट? द फर्स्ट पॉइंट विल बी दैट, एंड सेकंड पॉइंट विल बी दैट आई एम फाइंडिंग द मिनिमम इन रेस्ट, एंड आई एम फाइंडिंग minimum in rest, and I am not comparing with the exact above cell. Let me write it for you. Comparing with exact above cell. ये क्यों? Because that above cell is pointing to the same color, and which is what we do not want, right? Similarly मैं बाकी कोई भर लूँ यार, तो इसको भी करने के लिए again this is 2, right? Then I will take the minimum of this and this, so it will be 2 plus 1 3. I will update it as 3, right? Similarly last column के लिए मैं क्या करूँगा? The color saying is 3, right? I will take the minimum of this and this column, right? the the first and the second, so it will be 3 plus 1, that is 4. I hope you are getting the point that how I'm filling the matrix. Let's fill the last one. Again the color is 1 and I have to take the minimum, so it will be among 3 or 4. So what is the minimum? It is 3, right? So it will be 1 plus 3, let me write it here, it will be 4, right? Similarly here it will be 2. What is the minimum among 3 and 4? So it will be 3, right? 2 plus 3, that is pointing to 5. Similarly for this, for the last cell, the color is 3 as mentioned, right? Because I'm taking this color and find the minimum of the above two, uh, not exactly above, remaining of the बाकी सारे सेल्स जो जो मैंने बी उठाया, तो आई हैव टू टेक मिनिमम ऑफ आर एंड जी, राइट? तो इनमें मिनिमम क्या है? इट इज बोथ आर 3, so it will be 3 plus 3, that will be 6, right? And if you find, now this last row is saying that I have I have colored all the n walls and this is my thing. If I started with the r, then this is my answer. If I started with g, this would my answer, and if I started with b, this would be my answer, right? So we have to return the minimum of them. So I will say that 4 is minimum, and you can see the 4 is minimum here, right? Let us try run the same thing for this 1 5 7 5 8 3. Like again, we will make an n cross 3 matrix. N cross 3 matrix. Let me make it for you, and then I will resume the video again. Okay, so let us do the dry run, and then we will write the code. So this was the first color. This is the first wall. This vertical thing is representing walls. It is first wall, second wall, third wall, and fourth wall. And this horizontal number of columns, it is saying that it is color. So it is first color, second color, till kth colors, right? So what I have to do, if I have chosen the first color, I'm starting from this point, let's say, then the next filling of the matrix will be from the first row. So if I am taking this one, so the current color is pointing to 5, right? So I will say 5 plus the minimum of the remaining, that is 5 plus 7. I will say 5 plus 5, that is 10. So let me write it directly as 10. Similarly, the second color is pointing to 8, so I will take 8 and then I will take the minimum of 1 and 7, it will be 1, right? So it will be pointing to what? 9. Similarly, for this, for the second row, third column, the current color is 4, so I will take the 4 and I will say that I cannot, मैं above cell तो ले नहीं सकता यार, because I do not have to color the same thing. Same color से मैं color नहीं कर सकता previous wall को. So I will take the minimum of 1 and 5, that is 4 plus 1, that is 5, right? ठीक है, थर्ड से शुरू करते हैं. सिमिलरली तुरंत से इसको भरते हैं हम. तो 3 plus the minimum of 9 and 5, that will be 3 plus 5, that is 8. So I will directly write it. Then 2, then it will be 2 here, and then plus of minimum of 5 and 10, so it will be 7. It will be 7. Similarly 9 plus the minimum of 10 and 9, it will be 18. ठीक है. Now here the last column, 1 plus the minimum of above 7 and 18 will be what? Okay. Hmm. The minimum of 7 and 18 will be 7, so it will be 1 plus 7, that is 8. It will point to 8. Then again 2 plus the minimum of 8 and 18, it will be 10. Then 4 plus the minimum of 8 and 7, 4 plus the minimum of the rest of the 8 and 7, it will be uh, 11, right? 4 plus 7. Now you have colored all the walls, so just you have to return the same thing, the minimum of the last row, as we did in this question, right? So there is nothing difference from this question to this question. Only difference is that initially the k equals to 3 was fixed for each and every test case in the previous question here, but k is also varying. So that's not an issue. We will make again n cross k matrix and we'll do the same thing, right? How we can do the same thing, right? I have explained you the dry run. So give yourself a time of maybe 10 to 12 minutes and try to code yourself, right? Come back to the video again. So I think you were able to code yourself. Now let me give you the pseudo code that what are we doing here. And before that, let me give you the code which we wrote in previous, right? The first step was to maintain a DP array. Then we fill the first column. So the first two steps will be the same, right? And then third step will be iterating for rest of the column. So let's do that. So let's do that. So the first thing will be nothing but we will maintain a DP of what? N cross k, right? The second step will be that fill, let me write it here, fill first row of dp with k colors, right? This is the steps that we did. The third step will be iterate for rest of the columns, right? So I will, let's say what I will call, let's say use int itr equals to 1 to itr less than n and itr plus plus, right? So this is for to iterating in the walls, right? What next I have to do, that now I have been iterating in each and every row and starting from one, right? What I need to do, then I have to fill each and every column as well. So I will use a for loop for int I equals to 0, I less than k, I plus plus. Now I'm filling each and every cell, but for filling each and every cell, I need to maintain the minimum of my previous row, right? So I will run again a for loop to maintain the minimum of previous row. So from here there is one more for loop that will say to maintain minimum from previous row. Don't mind my handwriting, just follow the intuition, right? So for that thing, you just have to what? You have to just make a minimum which is pointing to infinity. Then what we'll do? You again use a for loop. Let's say j equals to 0 to j less than k and j plus plus. And one thing you remember, the first point was that you do not have to compare with the exact cell above, right? You have to compare with the rest of the colors. So I will say that whenever I is equals to j, right? This is my current cell that I'm filling with. Let me use a different color. This is my current row that I'm filling with. The current each and every column जिसको मैं fill कर रहा हूँ यार 8 7 and 18, और मैं इसको compare किससे नहीं करूँगा? When I'm filling 7 I will not compare with the above, right? So I will say that if I equals to j, do not compare, do not उसको आप consider मत करो minimum find करने में, right? So continue in the else case, then find the minimum, right? For the else case, you have to find the minimum. So what we can write here is that minimum is nothing but you will use the Java function that is math.min, and I'll compare it with what? Minimum. And then I'll compare with the previous row, right? For the previous row, I can use this ITR pointer -1, right? We'll go to the previous row, but with the same column. So I will say J, right? So we have got the minimum from our previous rows. I just have to place this thing, the ITR of J. I have to not J. I'm filling with I pointer, right? So I will say I, and I'm comparing the previous row with the j pointer. That's why I mentioned j here. At last, for this for loop, I just have to say that my current cell is pointing to nothing but the cost, the color cost. I have to take the color cost first. So itr of I plus the minimum from the previous row, right? That is what we were doing from the dry run. Now we'll complete all the for loops, and at last we'll just return the minimum of last cell, right? So let us code this approach, because this code is exactly this approach is exactly the same we followed for our previous question. तो अगर आपने यार ये क्वेश्चन कर रखा है, लाइक लेजिट आपने यार खुद से किया हो या फिर मेरी वीडियोस को देख के किया हो तो अच्छे से अगर आपने समझ रखा है, तो ये क्वेश्चन स्ट्राइक होना चाहिए था यार. ये जो वॉल्स कलरिंग है, ये क्वेश्चन आपको स्ट्राइक होना चाहिए. लाइक वी हैव डन समथिंग सिमिलर इन द पास्ट, राइट? तो अगर ये स्ट्राइक नहीं हो रहा है तो यार, लाइक यू नीड टू चेंज योर स्ट्रेटजी मे बी. तो आप मे बी अच्छे से पढ़ो, है ना? ठीक है, मैंने आपको सूडो कोड दे दिया यार. ट्राई टू कोड इट योरसेल्फ एंड देन विल मीट अगेन इन लेट्स से 10 minutes. Give yourself time, maybe 10 minutes. Yeah, 10 minutes will be enough, and then we resume the video. Okay, since I have given you the exact pseudocode that what all the steps are needed, then I will directly show you the code that what we have to write in the code editor, because let's not waste the time and make this video longer, and because we have to do one more optimization, right? Okay, so if we follow the same approach, then the first step was to make a DP array, right? So we made a DP array of n cross k. We fill the first row with the first row of the cost, right? Because if there is only one wall, then you have to return the first row. That's it, right? For the rest of the rows, we have to iterate for I equals to 1 to less than n, right? Then we have to fill each and every cell, right? For that thing, we have this another for loop. And for each and every cell, we have to take the cost thing, right? To fill the each and every cell, we have to take the cost thing first of all. This 1 plus 3 is coming from where? The first is the cost associated with the plus of the minimum of the other cells. Why we are taking minimum? Because if we have computed for n equals to 2, then why not use this row to compute for n equals to 3, right? Why not use that? So that's where the dynamic programming comes in play. using the sub problems, right? Okay, so and the first point I explained you, and you must also know if you have solved this problem, which you had obviously. So first point was that I am not comparing with the exact same cell that would because that would contradict with the question that no two adjacent walls are allowed with the same color, right? So that's the if statement is here. I'm not comparing with the exact above cell. I'm maintaining this for loop just for the previous row to maintain to find the minimum from that, right? So if it's I equals to j, do not compare it. For the rest of the cells, you have to compare it. And finally, you have to place the value on the cell. That is the cost associated with it plus the minimum you find from the previous row. I hope this step 2 is very clear. ये question so this step 2 is very clear because this is already something that we have done in the past. The optimization maybe will be a new thing for you, but yes, I let me explain you. So the last thing is for the last row, what we're doing for the first row. If there was only n walls, then you return the minimum of the first row, right? That was your answer. So for the last row, you have to do the same. Now the all the walls have been colored, so just return the minimum of the last one, and this is the very standard code here in an array. If you have to find the maximum, then you make a answer variable minimum, then you make answer variable with the maximum value, and then you keep on comparing it, right? At the last we will return answer. Then we'll now let's compile and run, and then we'll see that this code this approach gets submitted or not. So before submitting it, let's discuss the time complexity as well, because so let's discuss the time complexity as well. So it will be that we have used one n, then we for each and every cell to fill the each and every cell we already used n cross k, and for n cross k for each and every cell we are always iterating in the previous rows to find the minimum. So it will be n cross k, right? And let us view the constraint, that what are the constraint. N is 10 power 3 and 10 is also 10 power 3, right? So if you do n cross k, it will be 10 power 3, that is 10 power 9, which is definitely greater than 10 power 8, and our code will give us the TLE, although our approach is right? So let us verify that, and before verifying it, right, there is one base case also that you need to handle. That suppose you have walls which are greater than n, which are greater than 1, right? But you have colors only equals to 1, right? Then in that case it will give you an error. This code will break, right? So let us handle that case, that if the number of colors is greater than 1, but the color given, because the case starts from 0 to 10 power 3, but the colors given is only 1, then we cannot do then we cannot color in such cases, right? So for that case it has written, then you should return -1. So let us return -1. Let's compile and run. So we compile and run, and you can see that our output and their output matches. Let's now hit the submit button, and we will verify that the TLE comes surely for this case, because it is n into k square, which is 10 power 9 greater than 10 power 8. Let us see that, and then we will proceed ahead with this, with the other optimization. Okay, so as you can see, the one test case, okay, so 1118 test cases passes, only one has the TLA thing. So that's not an issue. So we have this understanding why the TLE comes, so you should understand. Now let us do the optimization. So for the optimization, I always say that find the recurring steps and then eliminate or optimize it. To find the recurring steps and eliminate and optimize it. This is our, what to say, mantra. Okay, so what is the recurring steps? That to fill n cross k, you have to use the complexity of n cross k. There is no choice. But what is the extra work that you are doing? You are doing again k that you are checking in the previous row, right? So is there any other possibility or any other way that we should not do this, right? While filling n cross k only, can we maintain some pointers, right? So that we can eliminate this k. Yes, we can. We have to just find the minimum, right? And we want that we are in this cell, right? And I don't want to compare with this cell, but the rest of the minimum I want, right? So I have to maintain two pointers, let's say m1 and m2, which will point to the minimum one and the minimum two, like the first minimum and the second minimum, right? So when I'm at this cell, I will check that if my above cell is pointing to m1, right? If it is equals to m1, then I will directly take the m2 point, right? If my above cell, let me write, if above AC, I'm writing AC, right? If my above cell is equals to m1, then I will consider m2, cost plus m2. And if it is not, then I will consider cost plus m1, right? I hope this thing is very clear. right? So let us do a dry run again for this case, and we will see for ourselves. Okay, so let us do the dry run, and then we'll proceed with the coding section. So somehow, suppose we have maintained the M1 and M2 in 1 and 5, right? When we were in the first step, in the second step where we were uh, pushing all the first row of Dupi with the K colors, in that moment only we maintain M1 and M2, right? So when I started my n cross k for loop, this for loop, the third step, then what I will do is I will check if the above cell is M1 or not. Because at this cell, I just do not want to compare with this above cell, right? Because that would give the same color. तो मैं बस ऊपर के cell से compare नहीं करना चाहता हूँ. I want to find the minimum in the rest of the cells. That's right. So I will say if the above cell is equals to M1, then you do not have to consider it, right? So there will be just there will be just if and else statement which will handle it. So it is M1, I do not have to consider it. I will take the M2 value, right? So I will say my existing color is what? 5, and I will take the M2, so that will be 10, right? So let me use a different color here, 10. So it will be 10. Similarly, if I'm at this point, the existing color is 8, right? You can see the matrix. The existing color is 8, and since the above point is not M1, you can directly take it. So 8 plus 1, 9. Similarly, for the existing color is 4, and since the above point is not M1, you can take it. So it will be 10, 9, 5. You can see the exact same row is printed 10, 9, and 5. Now, while you were printing this, while you were filling this row, I will again maintain the M1 and M2 here. So it will be M1 will be pointing to this, and M2 will be pointing to this, right? Right, guys? So let us fill the third row. The existing color is 3, and since the above cell is not M1, you take the minimum. That you take the M1. So it will be 3 plus 5, 8. So let me use a different color. So 3 plus 5, 8. Similarly, the next color is 2. Since the above cell is not M1, we will again take the M1. That is the first minimum. So it will be 7. Now for the third row, for the third cell, the existing color is 9, but since the above pointer is minimum 1, right? You do not have to take it. That was the first violation. So you will take M2 because M2 is the second minimum, is the minimum in n of the in the rest of the rows, right? So it will be 9 plus 9, 18. Similarly, while we were filling this row, we will again maintain M1 and M2. So it will be M1 and this will be M2, minimum 1 and minimum 2, right? Let us fill the last row and we will see for ourselves. So it is the associated color with this cell is 1, right? And since the above cell is not M1, you can take the M1. So it will be 1 plus 7, that will be 8. Similarly, here the associated color is 2, and since the above is M1, you cannot take M1. So it will be 2 plus 8, 10. The third row associated color is 4, and since the above cell is not M1, you can take M1. So it will be 4 plus 7, 11. As you can see, the entire matrix matches, right? And we have completely eliminated this. We have completely eliminated this extra kth loop by maintaining just 2 pointers, and just maintaining 2 pointers and 2 ifs. So it will be O of 1, right? So the time complexity now changes to n cross k square to n cross k, right? So that's the optimization here. So in each and every case, in each and every code, अगर आपको कोई भी optimization करना है, ठीक है, so you just have to find what are the steps that are repeating, try to eliminate them or optimize them, right? हमने इस केस में इसको eliminate ही कर दिया, but that step need to be done, right? तो उसे हटा के हमने O of k से हटा के उसको O of 1 में कर डाला. So that's the optimization you have to do when asked in an interview or when you are thinking something in terms of optimizing your code, right? So that is it. That is it. I have given you enough intuition, more than intuition, and a dry run as well. So try to code it yourself, right? And resume the video. Take to give yourself maybe 10 to 12 minutes, and that should be enough. And then come back to this video again, right? Okay, so let us do the manipulation in the same code because most of the things will be required. So in the step 1, we need to maintain some more pointers as well. So int m1 will be int m1 and m2, that will be pointing to infinity. So let me write that. So I have written maintain 2 m1 and m2, and while filling the first row in this for loop itself, I have to maintain the what is the m1 pointing to and m2 pointing to. And let me explain that how I'm finding that, and then I will give you the pseudocode, and then I'll ask you again to code it yourself, right? So let's say we have this element as 1, 5, and 7, right? We need to iterate as well, and we need to find the minimum, right? So my first m1 and m2 both are pointing to infinity, right? So the first element comes, and I will check that. Let's say if element is like greater than m1, right? Then what I will do, that I will say that you have to maintain m2 also, right? So first I will say that point m2 to m1, and then m1 to the current element. So it will be pointing, the element will be pointing to what? 1 and M2 will still be pointing to infinity, right? There will be else if statement as well, where we will see that if current element is less than M2, right, then I will directly say that M2 is equals to element, right? So let's do for I equals to 1. This was the for I equals to 0. So for I equals to 1, what will happen is the element is what, 5. It will say the 5 is it less than 1? So not, it is not. So it will go to the else statement and it will say 5, is it less than infinity? So yes. So update M2 as 5, right? So M1 will still remain the same, M2 will be updated as 5, right? So let us do the third iteration at this point at here. So the third iteration will be 7. So it will check with first M1. So it is M1, is it is what, less than 1? So it is not, right? So it will not go to the if part, it will go to else part. So 7, it is less, 7, it is less than 5, it is not. So then the third iteration as well, you can see the M1 will point to 1, M2 to 5, and as you can see that the smallest element was 1, which you pointed to M1, and the second smallest element in this array, which was 5, which is pointed to M2. I hope you are clear with this logic as well. This is the pseudocode here. I will write the same pseudocode in my first for loop as well as in the nested for loop as well. So let me write that and try writing yourself with me, and then resume the video. Okay, so I have mentioned that thing as well, the same pseudocode as I've showed you in my paint. Now in the third row, we need to eliminate this loop, right? So let us eliminate this loop first of all. Let us eliminate this loop. I don't want this loop. I just need to maintain the current pointers, right? But whenever we are going to the next row, suppose for this first row M1 and M2, we have find out, right? But for the second row, the M1 and M2 changes, right? That is, let us make two more pointers that will say that what is my current M1 and current M2, right? And then we'll swap it after each and every iteration. Okay, so I have written the same if, that if the above cell is, if it is equals to M1, then you take the M2, the second minimum, and if it is not, then you take the minimum, right? That's the code. That's the code here, and I've explained you the dry run itself. Same dry run मैंने आपको explain कर दिया था paint में यार, right? So now you have to update the M1 and M2 for next iteration, right? So let me write a comment here. So you have to update M1 and M2 for next iteration, right? For next idea. So what we can do here is that we have to run this same code, this 48 to 56, you have to same code for here as well, for this particular row, right? I have to run the same code. So let us implement that thing and come back to this video again. Okay, so I have written that code as well. मैंने आपको ये पहले explain कर दिया, इसलिए मैं live code नहीं करके दिखा रहा हूँ. Why to waste the time is very important. ठीक है, the same code है यार. When element is, if it's less than M1, right, then first appoint M2 to M1, then M1 to your the current element. Why I'm using CM2 and CM1? Because this pointer is maintaining the minimum 1 and minimum 2 for the next iteration, right? And then we will swap the values, right, to M1 and M2, because for each and every row हम compare to M1 and M2 से ही कर रहे हैं, है ना? So we are using just two extra pointers to find the minimum of the next row, and then we'll appoint again to M1 and M2, right? So that's the code here. Let us appoint the current M2 and M1 to our M1 and M2, so that the iterations go in the smooth manner, right? यहाँ पे वापस से compare M1 and M2 से ही हो. Let us do that. Okay. So after this for loop finishes for each and every row, right? For each for a row, when the each and every column are filled, then you have to appoint. We have to swap the values. So M1 points to against to current M1 and M2 to current M2, and then again the current M1 and M2 will play a role in finding the minimum for the next iteration, right? So again pointing it to integer or max value, right? That is it. I've already showed you the diagram, so the code will be much easy. It's a very simple and easy to understand, to digest as well. So ठीक है, the last में we have to return the minimum of last row, right? But we have already maintained that. So in that case, we just need to edit all these lines, delete all these lines, and instead of answer, I will return M1 here, right? I will return M1. So I guess that is it. We have made the changes, and let us see if the code works, right? So great. The compilation, the expected output and our output matches, and we have successfully emitted this O of k extra. So the overall time complexity will be now n star k. Let us submit the code, and let me see if I have not, the base case is there. Okay, so let us submit the code and we will see. So great, it is successfully submitted and we have scored the points. So this was a hard question, but not hard for us because we have already done the same question in a different uh, POTD streak, right? तो ठीक है यार, तो पिछले क्वेश्चंस को याद रखा करो. वट एवर वी हैव डन, इट विल बी यूजफुल फॉर ईच एंड एवरी क्वेश्चन वी एनकाउंटर इन फ्यूचर. So that's the main, that's the another motive to start this channel, from the brute force to the optimized approach. So let us meet again. Oh, before meeting again, there's one more thing I need to share. So that's the initiative that I've taken. So this is the optimized solution I coded in Java, which I showed you the exact code. This is on the left hand side. It is same thing coded in C++. So again, the language should not be a barrier for C++ users as well. The dry run is important. The intuition is important. The code we can do, right? That I can do in Java, so I can do in C++ for those who do in C++, right? So that's it for today's video. Let's meet in the another streak of day 133. Till then, you can connect me to LinkedIn or Insta for any doubts and guidance if you may have. Use the comment section constructively. Ask any doubts you may want, right? And I will definitely reply to you in the coming time, maybe, right? So let's meet again. And till then, keep learning, keep growing, take care, and bye bye.